Hey everybody, I'm Lex.
And I'm Austin.
With PDQ.com. Well, Austin, we're going to go back to, well, something I never really studied, man, today.
Right back to network basics. That's right. That's right.
So network basics, right? You're going to, I mean, this is a very broad topic. So today we're going to kind of just cover some.
Yeah, I would call it just the beginning steps, baby steps into more in-depth topics.
Baby steps? Kind of like, what about Bob, baby steps?
That's right.
Okay.
Yeah, exactly. You got it.
All right.
So just to be a little transparent here, this is also some Net Plus points of the certification. So this may help you if you're studying for your Net Plus certification.
Just to understand, right? You teach this.
I do, yeah.
Okay, so this is something you teach, obviously.
In my time in the military, you're constantly getting new people in who need to be caught up. Their time in their training wasn't very in-depth, nor do they really remember it. So once they get into the shop, somebody has to gather all the little ducklings and teach them how to move a packet.
All right.
So,
Mother Goose, let's do this.
That's right.
All right.
That's right. So I'm just going to go over some introductions of me and why I'm talking about this. Before I joined the military, I did computer networking for about 6 months, joined the military, did computer networking for 5 years, got out, and then PDQ onboarded me for using a veteran program. And then I've been here for about a year.
We saw him, we tackled him, we gave him the hug back.
That's right.
Now he's here.
That's right. So now they've asked me to do some networking basics, and I could talk about this for days. So let's jump right into that. Now, item number one for any networking teaching material or education is the OSI model.
I got to know what OSI is. It's been a long time, man.
So it's the Open Systems Interconnection Model. Honestly, I was probably told that one time 6 years ago and then completely forgot it and just know it via OSI.
Just so many acronyms here. This is going to be fun, guys, like alphabet soup today, right?
That's right. It's going to be acronym city. So the OSI model is not definitive. There are protocols that fit into each layer. We'll talk about what layers are in just a moment. I can reference 802.11 just off the top of my head. That kind of fits into multiple groupings, but it is a great teaching tool. When you're talking networking, you're usually talking layers 1 to 4. Now, when I'm saying layers 1 to 4, that's what you would call the bottom of the stack, right? If OSI has 7 layers, I'm going to go ahead and draw. I'm going to go ahead and draw that here. If this were the stack, and you've got 1, 2, 3, 4, 5, 6, 7.
That looks like the 7 layers of hell, man. That's a horrible drawing.
That is a horrible drawing. The thing is I on my resume, I did say that I could draw, but I never said I could draw well.
Oh, okay.
So that's what we're doing. If you were to split this up into 4 layers, and I'll go ahead and just erase all this.
Did I make you feel bad?
You did. It's okay. It's okay. So you've got the bottom 4 layers of the OSI model. 1, 2, 3. First layer is the physical layer. Does anyone have any idea what the physical layer is? Lex?
Okay, I'm assuming physical layer, that's going to be anything you can obviously touch, right? So your switches, your cables.
Exactly. Yeah. Fiber, Ethernet, any of those physical mediums are usually or typically within that layer 1 topology. You've also got...
does wireless fall into that too?
It does, yeah.
Okay.
Like I said, 802.11, the strength of the radio is something that you would call under the physical layer of the OSI model. So, like I said, physical has everything to do with the physical medium. Data link is where we start getting into actual protocols. There are some protocols within layer 1, but it's usually like frame checking. And making sure that the packets are aligned as they should be and sent across the medium. But once we get into layer 2, it's called the data link layer. So let me just go ahead and draw here. Layer 1, layer 2. Again,
you draw as good as I type, man.
That's exactly right.
I'm messing with you. But
it's okay. I do not draw well. But layer 2, you have protocols in here such as CDP, LLDP, but the point is that layer 2 has everything to do with something you would group into a like a MAC address, or if you've ever heard of VLANs, or if you've ever heard of a frame. And we can go ahead and get right into that here. I've picked a packet that we've got right here in our network, and if you were to grab this, and the reason that we're even talking about the OSI layer is because if you were to ever hop into Wireshark like we are now, they break it down by layers. In this case, that with TLS, you're not going to get any deeper than the layer 4 header, but that's all we're here to do, right? So if you were to hop in this layer 2 Ethernet frame, you would get information like this: source and destination MAC address. Within that header, within the actual MAC address header, there's more information.
So how does it know where that destination address comes from? Is that just...
Typically, if you are in the same broadcast domain, it would be via ARP. The computer can use its internal networking logic to figure out that the IP address that you're trying to communicate is in the same subnet as you. Therefore, it would just ARP for that IP address.
Okay.
If it recognizes that that subnet is not within its broadcast domain, then it will send that to the default gateway.
Okay.
So that's layer 2 in a nutshell. There's a little more here as well, but then you hop down to what we'll call layer 3. So that's where you'll find things like IPv4, IPv6. There are some layer 3 protocols outside of IPv4 and IPv6, but that's mainly what you'll see in this header. But you'll get things like, what would you call it? The DFSC field. You've got other IP flags, but basically this is where you'll see source and destination IP address, things like that.
Okay.
And if we were to scroll down a little more, go ahead and grab that. Thank you. We'll get into what we call layer 4. Layer 4 is where you'll see TCP, UDP, ICMP, things like that. Basically, these are the control. They sit on top of the IP layer, and in turn, let's just talk TCP for a second. It controls the flow of packets. I'm sure we all know this, that UDP does not care, TCP does care, things like that. But you've also got...
When you talk about caring, right? Like TCP, like I gave this to you, it wants the response back. Oh, I got it, right? And UDP is like, here you go, just take this, right?
That's right. Drop packets are not a thing that any receiver cares about in UDP. So this is just some terminology for you guys that we're going to talk about. I'm sure most people know about the OSI layers. I just wanted to sit down and
yeah, I'll tell you what, it's interesting, as much as I've done some studying on this, the way you explained it to me, and we did this yesterday, right? Kind of talked about it. I learned more yesterday than I think I've learned in a long time.
Well, I appreciate that. I hope you forgive my terrible drawings, but we'll go ahead and go ahead and move on.
No, I'm going to harass that the entire day here. So,
okay, perfect. That's what I love. So I'll go ahead and clear this. We're going to talk about some properties of network traffic, right? Like I had said before, when we're talking about the layer 2 network, we're talking about data links, right? Things that normally are sent via the same broadcast domain. So we're going to talk about a couple things here. We're going to talk about broadcasts as a communication idea within Ethernet, and then we're going to talk about broadcast domains, right? So does anyone have any idea what a broadcast means in terms of networking?
Okay. In return, broadcasting, right? I mean, obviously, I'm going to send some data, and hopefully it gets to your machine, but because I don't necessarily know where that goes, I'm just going to broadcast that out to everybody?
Correct.
Okay.
Yeah. So broadcast as a communication idea within Ethernet is a methodology to send one thing to everybody, right? This is done via some reserved addresses within Ethernet, as in a MAC address, or within an IP address as well. The broadcast address of a subnet will talk to everybody in your subnet, right? Mm-hmm. So normally when you talk about broadcast, you have to talk about broadcast domains, right? So if I here have a router and we'll say two hosts defined by these squares.
Let me just ask you a question in regards to that. That's a router, right?
Yeah.
Those two machines don't necessarily have to be on the same network. That router,
So in a perfect world, if they were if everything was set up correctly, then yeah, they don't have to be on the same network. That router internally is aware of both subnets.
So that could be just some machine across the internet.
It could, except that router would look more like a cloud and an interconnection of routers in between.
All right, I'm going down the wrong path, apparently.
It's okay.
Explain. This is, I guess, educate me, please.
It's okay. So when we're talking broadcast domains, you'll see this on plenty of tests. A lot of times I'll ask you, hey, in this picture I have on the screen right now, how many broadcast domains do you see? If you were to take a guess, Lex, what do you think?
I would say probably, one, right? You got one router, so that's going to take care of things that way? I mean, am I thinking about this wrong?
You're close. You're close here. So what you would say is, too, a router segments broadcast domains, right? So what you would call a broadcast domain is also what you could call a subnet. Or basically, if I were to shoot a broadcast in this network, who would receive it?
Okay.
And routers' ports are usually the stop-all for any broadcast. They don't switch packets between them in any normal situation.
Just use the word switch there.
That's right.
Okay.
So that's where things get a little tricky, right?
Okay.
So you've got two broadcast domains right here, right? That means if this computer sends a broadcast, the only people who can get that are any other devices hanging off of that port being
that
this guy
specific port right there
on the router,
Okay.
right? So how do you? In most situations, you're not going to see this, right? You're going to see a router that has a switch on it, like this, and then two computers.
Okay, so that's kind of where I was thinking things earlier. That's why I was thinking router. You'd have that would be routing to a different like site or cloud or something, but definitely a switch. Okay, so with the switch here, that would be its own broadcast domain.
So the way you can think about it is wherever your routed interface, you could even call it your default gateway is, that's where your broadcast domain ends, right?
Okay.
So if some broadcast protocol is on this network and it's trying to talk out to any other clients, do we have any ideas how many broadcast domain are right in this picture that you see on the screen? Do you have any ideas?
If I've listened to what you said, we just have the one, right?
That's right. So a switch does not segment broadcast domains. Except,
so that's it right there between the switch and the router.
That's right. A switch, as it is by default, and I'm gonna say that again, by default, if you were to plug two computers in a router, it would not segment via broadcast domain. Does anyone have any idea what can segment via broadcast domains? Do you have any clues, Alex?
I'm pretty sure VLAN would do that, wouldn't it?
That's right. Yeah. So you could throw a VLAN on this switch, and that is the virtual segmentation of broadcast domains.
So that would be a broadcast domain in itself.
That's right. So if you had VLAN 1 and VLAN 2, two broadcast domains, right? But in the context of just this drawing, I would assume that there's only one broadcast domain, right?
Should we take a question real quick?
Yeah, let's do it. Are there any questions?
Yeah, we'll start out with a nice, easy question. I'd tell you a joke about UDP, but you probably wouldn't get it.
Oh, what a classic joke!
Scott.
I think he's the third person to make that joke today.
I love that.
I've got one more for you.
Okay, hit it.
All right. What do you call a group of network engineers? An outage. Funny.
Actually, we do have another joke.
Do we?
Or not a joke, but an actual question.
Oh, an actual question. Okay.
Perfect.
If you really want one.
Yeah, let's do it.
All right. Hey, guys, with remote devices constantly connecting and disconnecting from the VPN and thus getting new IP addresses, I have to wait on DNS to update and propagate their new IP addresses before PDQ can reach them. Is there any way to speed up this process or force PDQ to use their newly assigned IP address? Thanks, Nathan C.
I'll go ahead and take this.
By all means, and then I've got a follow-up for whatever it is you say, because
Okay.
fun one.
So right off the bat, I would tell you to use the IP address scope that you have for that VPN. Forgo DNS, so that way you're not waiting for that replication to happen, and just use the IP range. That's just off the top of my head. Is that best practice? Maybe not.
I would say that would definitely work IP address wise, but if we're having to take care of DNS, we got to have aggressive scavenging, right?
That's right.
So we do have some videos. Thank you, Brig, on how to do that, aggressive scavenging. And if that's not fast enough, Jordan's got some PowerShell. Go on. Sorry, a little juicy there. Jordan, your PowerShell, man. Tell us a little bit about it.
So that PowerShell script is going to be more aggressive than you're thinking. It's basically, you can set that to run as often as you want, and it's going to aggressively scavenge anything that's even a second out of date. And then you're just going to want you to be refreshing your DNS on your server machine as often as that is scavenging. But that comes with its own risk. That will make scavenging pretty much instant, but there's a lot of risk that comes with that. So that's a use at your own risk there.
I'm going to agree with Jordan. Think about that one and maybe, test it. I don't know.
Yeah.
It just seems like an all or nothing once you kick that off. So
I think personally, if I were to scan a bunch of computers, and I mean, we've seen this even here in our environment. DNS takes a minute, right? Especially when somebody hops on the VPN. But you create an IP range that only VPN users will have, and then you can scan those computers just via their IP range, and then you can either. That's just what I would recommend. It's probably not going to look the cleanest in deploy or anything like that, but for the fastest and easiest method, I would just have a defined IP scope that you want to use for your VPN range, and then scan against that scope instead of scanning against host names. But that's just me.
Yeah, I don't think that script's actually going to solve any issues, but it will bring the networking team to the table to have a discussion finally.
There you go.
That's right.
There you go.
Get those networking guys to
Austin and Bobby be right at your desk.
That's right.
With the hug bat, right?
That's right. Hug bat, ready to go, ready to hug some fools. All right. All right. Any more questions? Or
keep going.
Okay.
Let's do it. Okay, we've talked about broadcast, right? One to all. The next step down would be multicast, right? As a topic, it's one to many. What I like to think about it is that one computer is sending a bunch of information, and then only a few computers are like, hey, I'm going to actually listen to this. It's kind of like when an email is sent here at PDQ. Sometimes I pay attention, and sometimes I don't. Sometimes I subscribe to those emails, right? So what you would call it is that the receivers are subscribed to a group that is sending or that has data within it that they will then obtain and use for whatever application.
Real world application, where would you do that?
Voice. If you've ever put somebody on hold, that is multicast typically, especially with a call manager setup, the Cisco call manager. Multicast is used to have that music playing constantly. It's constantly playing over the network, but your phone subscribes as soon as you hit hold. That's why when you jump on, if you've ever been put on hold, it sounds like the music has been played halfway through the song, is because it's always playing.
So that broadcast's always going on the network, but only a few, just the phones only are listening.
Right. You can subscribe and unsubscribe at any time with that hold button. Right. That's a good example. Yeah. That is multicast. I didn't really draw it, but using a switch, basically everybody receives that multicast packet in a normal networking setup. So if you had a switch here, we'll go ahead and erase that and go to black. If you had a switch here with 3 clients, I'm going to draw those with circles this time. 3 clients. This client is sending data via multicast. Everyone receives it, just like a mass email, but only some people care. Right.
So it's just discarded rapidly at that point.
It is.
If you're not subscribed?
Yes. There are technologies that Cisco and other vendors use to mitigate this noisiness, but if you were to grab your Netgear switch, throw it on the network, and start sending multicast streams, everyone on the network would receive it via the RFC, right? It is treated like broadcast normally. And I say normally, big star, big asterisk on that one, because I can guarantee that multicast has caused me plenty of issues in recent history. Okay, so let's go ahead and go to the easiest one to talk about, unicast. All right, one-to-one in communication. Sender and receiver is known. Sender and receiver is defined. If you want me to draw that, I can go.
Do you predefine that kind of thing? I mean, like, what would be an example of unicast?
Going to google.com. It's unicast. You're talking to one server and it's responding to you. Okay. Anything where it's a one-to-one based traffic, most internet traffic is unicast.
So do you have to set that up, or is that just a standard, unicast? Once I know where it is, that's where it goes.
Yeah, using IP and each layer of a or each header of a packet, you can reach that destination. Does layer 2 know how to reach google.com? No, but it knows how to reach the default gateway, right? And then IP knows how to get to google.com because of that DNS lookup. All these puzzle pieces fit together to make one beautiful network puzzle sculpture.
Beautiful network. I've never
That's right.
ever heard it described as beautiful, but
I would say that each network is beautiful and unique, and that's how I feel personally.
I like the head. Unique.
That's right, unique. But yeah, unicast is the easiest one to define. I won't go ahead and draw it here. I'm sure most of you understand how unicast works in that sense. It's one-to-one. So we're going to go ahead and talk about MTU. Now, MTU is the maximum maximum transmission unit. I don't know. I don't remember the abbreviations for it, but I can tell you what it does. So we're going to go ahead and take this mouse, use it to...
You got a mouse pad, dude. Here you go.
Oh, perfect.
Jordan hit it.
We're going to go ahead and look at this. We're going to go ahead and look at this packet specifically. Ooh. We're going to lower this. Sweet. Okay, so every packet has a maximum size that it can be, right? This is just defined via RFCs. This is how it's supposed to be. So if you were to take, when somebody says MTU, your MTU is 1500, let's say. What they're talking about is if you were to slice up the packet like Wireshark does here, each of these little categories is a header, right? When you're looking at this, when you're referencing the MTU, that starts from IP, or that starts from the network layer and moves up. So when I say up, I'm talking layer 4, layer 5, blah, 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 all the data that resides under layer 3. So when somebody says I have an MTU of 1500, that does not include the Ethernet header, which in our case is about 14 bytes, right? And then you've also got some overhead data on the actual layer 1 for some cyclic redundancy checks, all that good stuff. So when when somebody specifies an MTU, you want to make sure that it's referencing or you want to understand that it's the size of that layer 3 header and all the data underneath. Does not include that layer 2 header or anything with layer 1.
Okay, you can obviously adjust the MTU. I've played enough.
Yes, you can. Yeah, you definitely can. I think it can be up somewhere around 9,000 bytes. The exact number I don't have off the top of my head.
Okay, at what point? I mean, so I start going and I start messing with MTU, right?
Yeah.
I'm sure you've run across it being done wrong, because I know I've done it wrong before and eventually figured it out. But
I have, yeah.
So where would you do a 9,000 an MTU of that size?
I would say specifically only mess with MTU if you have complete control over hosts on each end and the networking devices in between, right?
An example.
Data centers.
So
we're talking file storage, specifically.
Like iSCSI?
Like iSCSI. If you want to send a lot of data a lot faster, you can up the MTU to about 9,000 bytes. But you also have to make sure that from source to destination and every single device in between.
So the switch, everything along the way has to be
router has to be ready to accept that 9,000.
I gotta ask the question, man.
What's that?
So I do it wrong. Somewhere along the lines, there's something set at 1500, the default. What happens?
Ah, perfect. I love this. I love this example. I even had this in recent history. So we had a router right here, a router right here, and let's go ahead and say that I was connected right here. Here's me.
Gotta draw some muscles on there, dude.
That's right. I can't get that fine on it. I'm so sorry. And then here's another computer right here, right? Defined with that square. So if my computer right here is set to 9,000 bytes, 9,000. Oh.
Wow.
9,000, just
Finger
like that.
paints, man. That's some interesting writing. Okay.
I know. Hey.
Okay.
And you were to, let's say that this interface right here is also 9,000. Holy moly.
Just do 9K.
Yeah, 9K. That
There
works.
we go. There you go.
A lot faster, a lot
9K.
easier.
There you go. Okay.
Simplify.
So what I'm drawing is the interfaces next to these MTU values, right?
Okay, well, time out. So the interface into the router has to be 9K, the interface out has
Yes.
to be. So there's like 1, 2, and just in the router itself.
Exactly,
Okay.
the entire path. It's not just the device and one line that says, hey, I'm ready for 9,000 bytes of MTU.
Bring it
It's
on.
every interface along the path. That's why you're not gonna get 9,000 bytes of MTU out of your ISP because the standard is about 1,500, right? But in this case, we had full control, so it didn't really matter as much. But let's say it was about 1.5K right there on that interface. And then just for fun, we'll draw 9K here, 9K here. Oh my goodness, this pen is failing me. I'm so sorry.
Is it the pen, really? Is it?
It's also the mental fortitude I'm exerting. No, just kidding.
I always heard that people who think really fast have the worst handwriting, so you must think really quick.
It's also because I am terrible at writing. I type all day.
So that one, 1,500 right there messes the whole thing up.
It does.
Does it mess it up, or will this auto?
It will cause traffic to not act as you suspect. Let's say I send one packet, 9,000 bytes, across this entire segment. As it gets here, it's just fine. As it comes out, it's just fine. As it comes in this interface, on 1.5K, the router will have to start fragmenting that packet because it's only expecting.
Whoa, fragment. And every time I hear fragment, I just like freak. I'm like, fragment. Something's wrong.
Let's say this. It's about it's dividing that packet up into easier to eat chunks.
Oh, 1,500K segments.
That's right.
Okay.
So 1,500, you take 9,000 divided by 1,500K. That's how many packets you have to regenerate from the router, and that's just one packet, and then get it to the host.
So it's actually slower at this point.
It's slower in all situations.
Okay.
It causes more CPU usage on the router because then it has to defragment the packets and reroute them.
Okay, so I'm gonna go out on a limb here. Take the default.
I would say stick with the default. Do not change the MTU unless you are absolutely sure that you are that you are in complete control of every device in between. And even then, I would suggest kind of just leaving it unless you have a very specific use case.
That's interesting. So, okay, did I hijack your MTU discussion, or did that?
No, actually, that is it for today's lessons. At least for what I have planned. We can continue if we have.
Should we do some questions?
Yeah,
We got some other stuff.
Let's throw on a few questions.
Okay.
All right. Hey, guys, I'm toying around with using WUFB. What does that stand for? What up, Facebook? No, I'm kidding. For a few device groups in my organization. Before I do, however, I'd like to try using PDQ to set up some detailed reporting on Windows updates, what's installed, when, etc. Would this be possible? If so, are there any best practices for the setup? Thank you, Aaron H.
Ron, let's see. Detailed reporting on Windows? Absolutely. I mean, okay. Again, if you open up inventory and you go look at applications, you look at hot fixes, okay? You can even get as far as running PowerShell to pull information in regards to Windows updates. Anything you can find in there, you can do a report on. So yeah, it can be as detailed as you want. I would absolutely highly suggest you dig to that level before you, well, obviously, make that attempt. So, Jordan, any thoughts?
Just the PowerShell scanner we have for scanning for updates was finally approved for the change we made a while ago, where if you have a WSUS server, you can now just specify that as an attribute. So it will now work whether you have a WSUS server or not. You just might have to make a minor change.
Is that available right now?
It's up on the PowerShell scanner on GitHub.
On GitHub, sweet. What else we got?
Let's go.
Hey guys, are there any plans to bring back some kind of remote scanning agent for inventory? I currently use another product and PDQ inventory side by side, and one of the few reasons we are keeping the other product around is because of its remote scanning agent for off-network laptops. Thanks, Andrew.
Andrew. Oh, that's cool. So, we hear you, and we are working on a remote solution for you guys as we speak.
Yes.
Yeah, let's leave it at that. What else we got?
All right. Hang on. Here we go.
Hang on, it was too fast. Hey, I'm in the speed round right there, baby.
All right, we got the speed round. Will there be networking dance routine as part of this webinar? The first one could be the TCP IP handshake.
You want to do one?
No, should we? I'm going to floss. Or are we going to? Oh, a handshake. Here we go.
We got to dap it up. TCP IP handshake right there. That's our official. That's our official.
I'm surprised we actually were able to do that. We're IT guys.
That's right. We were very.
There was the handshake.
It was very fluid.
Check it out. I'm a UDP this.
I love it.
Did he get it? I don't know.
That was a great joke. I have never heard that one before.
You've never seen a joke like that?
I have not.
Any other questions?
Sure.
You know we're out of touch with what's cool, and we think we did something cool there.
Wow. If we have to declare it, yeah, that's a good point.
You guys are dads. Oh. All right. Hey, guys, should the MTU still remain the default 1500 for 10 gig connections, or will you see a big benefit setting it to 9K? Craig M.
So, okay, when we're talking MTU, it really is what I would almost call it what's best practice. When you're working on data storage networks, it is best practice to set that MTU to a higher value, so that way data is transferred faster, and they are 10 gig links in most scenarios.
Again, we just want to, that's like your iSCSI connection. We know exactly where it's going, what's going across, so you've got control of both ends of that, right?
Right, exactly. Okay. If let's say theoretically you had one switch and you could control MTU on every interface, and in this scenario, you had 10 gig links on every interface, and from one computer to the other, you set MTU to 9,000 on the computers, MTU 9,000, and then you transmitted some data, it would be faster. That's the law.
If I introduce the internet to that, we go out to the rest of the world.
If your ISP is not going to have an MTU of 9,000 unless you have some specific contract with them that specifies that. I think there are some private circuits that allow you to adjust the MTU. That's why data centers can have data storage networks that span geographic locations, right? But in your basic ISP setup, they will not be expecting 9K as the MTU. Therefore, I would not do that unless, like I said, unless you have control of every single device along the path from the source to destination, do not change the MTU value. That is my recommendation. Salute and
what he
star.
said. What he said.
Exactly. You can stamp my name on that one.
Well, this kind of goes along with that. Dear Lex and Austin, would it cause an issue if you set the MTU higher on the router, but if it is the same size on the destination and source?
No, you would not. The cool thing is that in the TCP header itself, there is a what you'd call a negotiation for size, for maximum size of that packet. It's called a maximum segment size, MSS. So if you have 9K on every device, but you have two computers that are at 1500, right? When they're setting up a TCP connection, they're going to say, hey, my maximum bandwidth is 1500. And then the far side will say, okay, yeah, me too. I accept those terms. And it will negotiate to the lowest segment size. So what you're doing is kind of creating a bigger pipe for traffic to go through. You're just not using all of that MTU value when you're sending data. So you can set 9K across all of your networking devices and then leave your host devices at 1500 if you so choose. And using TCP applications, you should be just fine. UDP applications are way more finicky because some programmer has to set those values. There's no checksum. There's nothing checking how big that packet is necessarily. So we're just specifically talking TCP. Yes, as Stuart says, there's the guide for MSS if you need any help with that. But yeah, you can set your intermediate network devices for 9K MTU, and your devices should be able to negotiate properly just fine. So that is another stamp, another
Austin approved.
That's right.
Austin approved opinion.
That's right.
I love it. What else we got, Kelly?
Well, we got two more.
Oh.
Hey, guys, can inventory show the install date of Windows Store apps? Sincerely, D. Martin.
Now, I do believe Windows Store apps are stored differently, aren't they, Kelly? Because they don't show up in program files. Or not Kelly, Jordan, right?
Yeah, they're stored a little bit different. If you're on like the GetAppX package and select all the fields available, there's nothing in there for install date. So I'm not going to say no, but it's something that I'd have to definitely look into on how to go through and find that out. I can do the research and I guess answer it next webcast, but I'm not sure off the top of my head without the defaults.
Jordan's saying that it's a PowerShell, right?
That's right.
Yeah, almost everything with the AppX packages is easier controlled to PowerShell.
Yeah.
That's right. The PowerShell Pro over there. We love it.
All right. And our final question of the day, what swag are you offering and how do people win it? From Stuart Smiles. Stuart, I do believe we are offering whiskey tumblers today. You win it by submitting questions just like you did. And Stuart Smiles, you're a winner.
Woo! Is he really?
Yeah, I'm going to let him win.
That's cool.
See how easy that was?
That was awesome. The voice and everything.
That's pretty poggies. I'm not going to lie to you.
Hey, if I ask how to win a bottle of whiskey, do I get one?
No.
No.
You are not allowed. No.
I'm not allowed to. Dang it.
How do I win $1 million, PDQ? Can you?
There you go.
Can you tell me? Can you help me?
Learn networking.
Well.
Learn networking.
No, not even close.
Buy GameStop.
Is that it for today, guys?
That's it.
That's it?
Poggy's show, guys.
Well, hey, thank you guys for watching. That was, I got to say, highly educational for me at the very least. Thank you, Austin.
You did not fall asleep, and I highly appreciate that. Thank you.
Are we doing more?
I would love to do more. In fact, if we could make this a series, which I think is the plan.
We should make a series out of this?
Let's do it.
Okay, I like it. Well, hey, I'm Lex.
And I'm Austin.
We're with PDQ.com. Thanks.
Thanks for joining our webcast today. Congratulations, Stuart Smiles and Aaron H., winners of PDQ swag. Send us your info at webcast@pdq.com. Thanks again for joining us, and we'll see you back here next week.